So in this video, I want to talk about Friedel-Crafts acylation and a couple of reactions. Okay, so remember the general reaction rule is that if we take benzene, okay, and add a lowest acid. In this case, I'm going to choose aluminum trichloride, in some sort of our our carbonyl group Cl, then we get carbonyl that's bonded to my R. So I lose my chlorine. So with that being said, let's look at a couple examples. So if I take benzene, okay, and I add, let's say let's do this. Let's do this molecule here, okay. If I add this molecule here and aluminum trichloride, then what I get, I'm going to lose my chlorine and I'm going to be bonded to my carbonyl group. The chlorine acts as a leaving group, okay, and I get acetophenone flavoring, okay. If I take benzene, okay, and I add this molecule here, okay, and just for you guys' sake, this is actually pH actually stands for phenyl group, benzene ring. Okay, so that's what pH stands for. So if we add this in some sort of lowest acid, then this is what we actually get. Yeah, and we have our phenyl group here. We could draw the benzene ring if we want to. Okay, I'm just trying to save space right now. Okay, now what if I take benzene, okay, and I add this molecule here and say rust. I'm gonna do rust this time. Okay, what would happen? Well, again, I'm gonna form a bond between my carbonyl compound and I'm gonna lose my chlorine. Okay, so in this sense, I form a bond between my carbonyl group, okay, and whatever is still left on it. Okay, now I want to talk about something here. What if you were given well, no, let me go a step further. Remember we learned about Clemmensen reduction? So we take zinc and HCl, okay? And what this does is that it actually takes away the carbonyl. It takes away the carbonyl, okay? So zinc and HCl takes away carbonyl, and so this is what we would form. Okay? Carbonyl just disappears. So that's something to know. So maybe you were given this specific molecule on a test and they asked you, okay, well, make this from benzene and an acid chloride, okay? Well, you would have to do Clemmensen reduction. So this is called Clemmensen reduction, okay? So you would have to know that, okay? So what if I take benzene, okay, and I add this molecule here? Okay, what would we get? Well, again, I'm always looking for my chlorine, my carbonyl carbon is, right? So if I take this and add it in, let's say aluminum tribromide, okay? Aluminum tribromide, what would we get? Well, I still have my benzene ring. Now I'm getting bonded to my carbonyl group, carbon. So I'm going to lose my chlorine. So if I'm looking at this, I'm bonded to my carbonyl carbon, and then straight down, I have two alpha groups on either side, okay? So that would be the compound that, I would form. Okay, so these reactions are pretty much straightforward. The thing with, and again, say for sake, we want to reduce this ketone here. We use zinc and HCl Clemmensen reduction again, and we get oh, no, I'm sorry, that's still that's silly. Okay, so we get the ketone to be disappeared. Okay, so again, these reactions are fairly simple, straightforward. The only thing that we need to know is that, and the reason why these reactions are straightforward is that because there's no carbon-cation rearrangement. It's just straight, acid chloride, give me benzene and lowest acid. and I just put on my my group, expelling the chlorine. Okay, so this will be all for this video. Pretty simple, straightforward reactions.